one of the keys to this test is going to be recognizing what kind of problem that you have. So I tried to kind of focus our review around that. So we're going to talk about 3 types of problems we had in chapter 10. And we'll talk about 5 different kinds of problems we had in chapter 11. So in chapter 10, the prevailing question all chapter long was the question, how many? Almost every problem started with the question, how many? And so you know if you see that, then you want to look for one of 3 things. Okay? One of the things you got to look for is you got to ask yourself if it's an or problem. And it's going to be pretty obvious if it is. How many people like broccoli or cauliflower was how we started off this whole conversation. And so if it's an or problem, we're going to need to apply the or formula, which said the number of ways event A or event B can occur is equal to the number of ways event A can occur plus the number of ways event B can occur minus the number of ways event A and event B can occur. And I kept saying, don't try to figure too much of this out on your own. Recognize the kind of problem and immediately go to the appropriate formula. So if it's an or problem, you're going to want to bust out this formula. Okay. Another kind of problem that we had in that chapter was an at least one problem. How many ways can at least one of something occur or be obtained? Sometimes you would see. And we actually applied the complement rule here. The complement of at least one is 0. So we applied this formula. The number of at least one is equal to the total. When I say the total, I mean the total number of things that can happen minus the number of ways you can get 0, because 0 is the complement of at least one.
David?
Yes.
Can you hear me? I'm here finally.
Okay. Well, thank you.
These pages, something happened to my email. It just went out altogether.
Well, I had sent those to Beth on Thursday, so that's kind of why we had the confusion there. Okay, so if it's one of those, go to those formulas. If it's not one of those, then you want to go back to those 2 questions we kept asking. The first question was about repetition. Is repetition allowed? Now, if the answer to that is yes, then the first thing you want to do is you want to draw blanks, and 9 times out of 10, that'll be all you need to do. You'll be able to fill in the number of ways each blank can occur, and then multiply those together. But occasionally, do you remember that we called that the fundamental counting principle that failed because it didn't meet the uniformity criterion? Okay, in other words, we'd get to a blank and we'd say, well, that'd be this number if this happened previously, but it'd be a different number if something else happened previously. So on rare occasions, if you can't draw blanks, then you may have to go to the tree diagram. We're going to look at an example where you have to do that. Okay, but if repetition is not allowed, then we ask the second question about order. So do you remember what our strategy was if order did matter? If the answer to that question was yes?
Yes. Permutations.
There's a permutation, good. And if the answer to that question was no, then we used a combination.
Combination.
Okay, so what I have written here so far, that's your big picture idea from chapter 10. Those are the ways you're going to have to think big picture wise. Okay, now let's practice problems and kind of get a feel again for the kind of problems that we were dealing with. So, for us to practice problems, get the review pages out that I ran off for you and sent to you. Some of them might say chapter 10, some of them might say chapter 11. In the old version of this textbook, it was chapter 11. In this version of the textbook, it's chapter 10. I think I marked out the 11, put 10. So, anyway. Either way, the first problem on it should be 8 factorial. Right? This page here. Is that what everybody's got in front of them?
Yeah.
Okay, so the first problem I want to look at from that handout together is number 6. And let's see if we can get to the appropriate counting strategy on number 6. So here we go. A race includes 5 participants. In how many ways could first, second, and third place be awarded? Don't try to get to the answer. Go through your line of thought here. So the first thing we're going to ask ourselves, is this an or problem? No, it's not that. Is it an at least one problem? No, it's not that. So we're going to be down here. So we're first going to ask, is repetition allowed?
No.
Why is repetition not allowed?
Because it's asking first, second, and third place.
They're not going to finish both first and second, are they? Okay. Does order matter? Is Daniel, Karina, and Donna the same thing as Karina, Daniel, and Donna in this case? Are those two the same result? They're not. So does order matter? Yes. So we're with a permutation. 5 things, 3 at a time.
Got the other one.
Thank you. And doesn't that turn out to be 60?
Yep.
Awesome. Okay. Mr. Black, this seems easier now. Well, that's good. Let's keep the train a moving here. Do what? I'll let you know what formulas I will give you and which formulas I will not before we leave here today. Okay, the next problem I would like to look at together is number 7. Let's read. Fred, Jerry, Peggy, and Juanita go to the ball game. In how many different ways can they sit? Okay, let's consider that question first. Is that an or problem? No. Is it an at least one problem? No. So then I go to the questions. Is repetition allowed? No. Now, does order matter?
No.
Okay, let's change the question. Mark out the word ways. Put the word arrangements. And how many different arrangements can they sit? Okay, now does order matter?
Yes.
Yes, it does. So do you see that this also is going to be a permutation? How many am I choosing from?
4.
How many am I choosing?
Four.
Choosing all 4. So a permutation 4-4, does that turn out to be 24? Okay, now that's the first part of that question, part A. Part B. How many ways can 2 of them go together to get popcorn? It's not an or, it's not an at least one. Is repetition allowed? No. Does order matter? No. If Daniel and Karina go to get popcorn, that's the same thing as Karina and Daniel going to get popcorn. So the second problem is a combination. We're choosing from 4 and we're choosing 2. Hey class, what's a combination 4 to? 6? 6 different ways. Hey Mr. Black, I just kept practicing and now I am getting this. Way to go. Congratulations. The next problemo I would look at here with you is going to be number 8. There are 4 different questions on a survey. Each question can be answered agree, disagree, or neither. And how many different ways can the questionnaire be filled out? Okay, it's not an at least one. It's not an or. So let's go to, is repetition allowed?
Yes.
Yes, it is. I could agree on more than one question, right? So this is blanks. How many blanks? 4 blanks. Okay, 4 blanks. 4 parts of the question. How many ways can each blank be filled in?
3.
Well, the first blank could be agree, disagree, or neither, and it couldn't be anything else. And the same thing for the second, and the same thing for the third, and the same thing for the fourth. And if you take 3 to the 4th power, you're going to get 81. How are we doing so far, class?
Yay!
Okay. Shove that up to the corner to kind of keep it on the screen, but it needs to be smaller. And draw another line. The next problemo that I want to look at, so looking at number 14 next, in a room of 20 people, does yours say 8 like Mexican, 6 like Chinese, and how many does it say like Mexican and Chinese?
3.
3, that's what I wanted. Okay, mark out the question. I don't want you to have how many of the 20 like at least one of these 2 types of food. I want you to ask the question, how many like Chinese or Mexican? That's the question I want you to ask. So let me blow it up on your screen here a little bit. How many like Chinese or Mexican? That's what we're after. So is this an or problem?
Yes.
Yes, it is. So apply the or formula. So why don't you guys write out the or formula, and then I'll catch up to you. So hopefully you're in the process of doing something like this. The number of Chinese or Mexican is equal to the number that like Chinese plus the number that like Mexican minus the number that like both Chinese and Mexican. And once you get it into that form, then it's just a matter of filling in the blanks, right? Okay, so the number that liked Chinese, the problem told us was 6. The number that liked Mexican, the problem told us is 8. Minus the number that liked both is 3. And so there are 11 in this scenario that would like Chinese or Mexican. How many of those do you want on your test? Okay. Daniel's saying yes. He's giving me yes head shakes.
11 at least.
Okay. 11 at least. Holy Toledo. That's a bunch. Okay, the next problem is going to be number 16, which you don't have. Okay, so 16, in a series of 4 on-off switches, no 2 adjacent switches can be off. How many settings are possible? Okay, so first let's recognize what kind of problem we have. So here's how the line of thinking would go. Is it an or problem? No. Is it an at least one problem? No. So then I would ask, is repetition allowed? Is repetition allowed? Yes, it is allowed. Why is it allowed? Because I can't have 2 offs in a row, but I can have 2 ons in a row, right? So technically it is allowed. Okay, so my first line of thinking would be, okay, I'm going to draw blanks. All right, so then I think about the first blank. It could be on or off, so that's 2 ways it can happen. Let's think about the second blank. How many ways can the second blank be?
1.
Okay, tell me why you think that, James.
Because if the first one's an on, then if the first one's an off, it can only be an on since no 2 adjacent can be off.
Okay, but what if the first one's on?
Then it can be, okay.
Then it could be 2. So do you see that we have failed the uniformity criterion here? We don't know if the second blank is 1 or 2. So now what are we to?
Tree.
Now we're to the tree diagram. That's right. Our blanks failed us. So if our blanks fail us, that's when you know you're going to do the tree diagram. Okay, so the tree diagram here would be, let's think about the first switch. Can be on, can be off. Let's think about the second switch. If the first switch is on, the second switch can be on or can be off. Holy Toledo, it's scary and I think Cairo, I'm not sure. And if the first switch is off, then the second switch is on. Let's go to the third switch. If the second switch is on, then the third switch could be on or off. Thank you, Shamari. If the second switch is off, the third switch has to be on. If the second one's on, it could be on or off. And now we'll go to the last switch. Every time we see on, it's going to split into on or off. So this one can be on or off. But every time the third switch is off, the last switch has to be on. So it's on, off, on, off. The last one has to be on. 1, 2, 3, 4, 5, 6, 7, 8 ways to set those 4 switches. Everybody golden?
Yes.
Karina, you good there?
11.
Okay.
Wait, so is the I the off or the on?
It's the on.
Oh, okay. So
This one was, I had to put on and off, otherwise the 1 and 0.
Okay. Okay. The ones are on and the zeros are off. That's it.
Can we do number 9?
Well, not right now, but in a little while we'll see if we have time, and we can maybe do number 9. But right now, I want to go to 17 if everybody's ready for it. You take a 10-question true-false quiz. In how many ways can you get at least one problem right? So, it's not an or problem, but it is an at least one problem, isn't it? So if it's an at least one problem, I'm going to go to the at least one formula. The at least one formula says the number of ways to get at least one correct is equal to the total number of ways we could fill out the test minus the number of ways we could get 0 problems correct if we fill out the test. So we've turned this into a problem where we got to do 2 easier things than the one great big thing. So let's think about the total first. How many ways can a 10-question true-false test be filled out? Okay, it's not an or problem. It's not a at least one. That part of the problem is not at least one. Okay, so is repetition allowed?
Yes.
Yes, it is. So I'm going to draw blanks. How many blanks? 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many ways can each blank be filled out? 2 ways. So do you see that the total is going to be 2 to the 10th power, whatever that is? Minus, how many ways can you fill out the test where you would have 0 problems right? One way, and that's if you miss every single problem, isn't it? There's only one way that can happen. The answer to this problem is 2 to the 10th minus 1. I don't know what that is. You can use your, actually, 2 to the 10th is 1,024, so 2 to the 10th minus 1 would be 1,023. Okay, so there's you a little bit of a run through chapter 10. Okay, so for the chapter 10 part of the review, here's what I would do. I would do the rest of the problems on this review that I've given you here. Okay, some are going to be very straightforward. Most of them that are left are fairly straightforward. A couple of them are a little bit harder than the other ones. Okay, and if we have time at the end of class, I'll let you write down the answers to all these. If we don't have time, then I'll send them to you. It'll be later this evening when I get to that, but I'll send them to you if we don't have time. So I would do that. And then in your textbook, I would also work page 575. Problems 1 through 3. I'm just giving me trouble here. There we go. 1 through 3. I think we can. Yeah, let's go with that one. 6. 9 through 16. 18. 23. 24. And I think that's good. Okay, so if you know how to do the handout plus all these problems, you should be in pretty good shape from chapter 10. By the way, all of the answers to this assignment from your text, all of them are in the back. It's a chapter test, and your book has both even and odd answers to those. Okay? So there's your chapter 10 review.